Hey there, I recently bought myself a bathroom fan, but the thing about bathroom fans, if you find a modern looking one, some kind of attractive, it usually doesn't have any kind of functionality like a timer. And those that do are very expensive. So instead of looking for that, I solved the issue myself by getting myself a module. And the thing about modules that are always connected, they usually have a standby current, but I don't like that. I really hate the thing that will pull the power from from the grid at any time. That doesn't make sense for me. I just need the bathroom fan to work, for example, for 3 minutes when I need it, and then it just disconnects itself. But only when I actually need it. So instead of doing all of this, what I did, I got myself this type of module. It is a relay switch with a timer. You can set the timeout in this instance from 0 to 10 minutes. It is usually in a range from 30 seconds to 10 minutes because it's really hard to set it up to a lower value. And other timer modules are usually for a dinner rail that are bell type of switch module that you can turn on, for example, a light somewhere and go down the stairs or do something and it turns itself off. But all of those modules have a standby current. They pulse power. So instead of doing all of that, I decided to fix it myself. So in this instance, and I'm not using any other entry apart from powering the module. And let me show you how that works. Let me turn on. See, 0 watts. Okay, I will connect my setup over here. This is my switch. It's just a 2-position switch. You could use a bell switch type of thing that kicks back and turns itself off. So let me turn it on. See, light is on. I can disconnect it. The light still is on, and until the timer expires, it will be on. Let me speed it up for you. See? And now, looking at the wattage, 0, absolute 0, nothing is there. When I connect it again, I can connect the light or fan for how many time I want in case I decide it's very humid or something like that. I want it on permanently. It will expire the timer, but it won't expire the light whenever the light is permanently on. If you have a bell switch, you won't have this functionality. In this case, I'm using that. See, the timer went off. The light is still on because the switch is on. I can turn it off and it's completely off. Again, 0 watts. Okay, so let's take a look at the schematic. Let me turn it off because it's whole life over here. Not great for touching it. So let's take a look at the schematic. I have everything here. The only thing that isn't on this schematic for the timer module I drawn here is a normally closed contact. So this is a situation when you will have these two are connected even when this is off. This is normally closed. Currently it is off. It means that you can use it in the different way. You disable it for a few minutes, for example. So let's ignore that for a moment. All other terminals are over here. So let's go through this. Keep in mind that this is spec'd for full AC voltage as a relay, so it's safe to use. Some of those relays are set only for a low current DC, so it's a good idea to look for it. Okay, so what we have here, we have a neutral. Let's start with a neutral. Neutral is permanently connected to the module. It's like normal light, you only turn on the light for whatever you need. You are switching here the live. Neutral is usually connected directly. Okay, neutral is also connected to the receiver, light, fan, whatever you need. Okay, and keep in mind this is permanently connected. You don't have to think about it. But we are switching live. So we go here with live, and live is permanently connected to one of the contacts, but it's only a common contact, which means it is not, in fact, in this case, because there is no NC connection, it is not connected to anything here. These are disconnected. You can think of a switch, of a timer-based switch between common and normally opened. So this is only connected. You don't need to worry about it in this case. But once we close the switch, so once I push it here, it connects here. It connects my timer module. It connects those two terminals, which means it connects live to my receiver, light, fan, whatever. But what it also does, when I close this, it connects live, goes through here. This is a connection made, and then it goes back here. It backfeeds the live again. So when I disconnect this, this switch, it means that it is still being powered through here, because the relay was connected. It is, the live comes back to the module, which means the module is self-powering itself using the relay. It is connected using itself via relay. So it connects itself to the live again, which means that it keeps the live connection to the module until the timer expires. Once the timer expires, this connection over here is broken, lights goes off or fan, and the connection to the live of the timer is also broken, which means it doesn't take any power. And so this is really good. But if you keep the connection live, it means that everything is still connected, timer can expire. So this connection, this is switched for a very long time. The module is still powered, but the timer expires, so it turns itself off, and the light is still on in this case because it's connected directly over here, which means you can have it on indefinitely. It will take a little bit extra current of the module being on, but it's probably a fraction of what your light or fan will take. So you don't really have to worry about it that much. But it will expire itself. It will disconnect this connection. It will keep itself powered through here. And then once you turn off that switch, it disables everything because this wasn't connected before anymore. So this is how it works exactly. I hope I explained it in ordinarily fashion, but what I really like about the solution is that it doesn't pull any current from the wall when I'm not actually using it. So only when it's turned on for the time being of the timer until it expires. Thank you so much guys for watching, and see you guys next time.